Ready, everyone? Shall we? Alright, guys, let's go. Alright, guys, in your infrared spectrometry, right? Okay, so basically we use infrared spectrometry to identify different type of absorption. Alright, guys, I want you guys to highlight this absorption. This absorption is important. Okay, every time you look at date around 1,700, right? This is very important, yeah. Alright, guys, for OH, right, it's also very important. Why got firework? What day is today?
1 month of Chinese New Year.
Alright, guys, we always read it from this way, yeah. Okay, so always try to read it from this way, okay? Hey, good. Okay, guys, I'm not sorry. I was having a discussion earlier. Okay, guys, remember we always read it from this way. Okay, and next. Okay, let's look at this region. This region is kind of nonsense, Basically, guys, try not to read it from your right hand side. If you want to make your life super complicated, right? Try reading from your right hand side. Bro, please don't, yeah. Reason being here is very messy. Like, we hardly get any info here. This region, we call it as a fingerprint region, yeah.
Fingerprint.
Yeah, fingerprint, like nonsense. Don't care. Okay, so guys, if you see a sharp ding that looks something like that, right? We call it as a strong absorption, yeah. Okay, then guys, if you see a fat one, okay, this one is a giat, Yeah, a fat giat. Ooh, a giat, right? Okay, so yes. So when you see a giat, this is also known as a strong or broad absorption. Yeah, that's a giat.
They asked for what's strong.
You have to mention like, oh, strong absorption. Okay. So at the right hand side, the pig become highly complicated. We call it as a fingerprint region. Yeah. So we always look at the key pig to identify. That's it. Okay, guys, next page, please.
Why is Asian so unathletic?
Why is it so?
Unathletic.
Why?
You mean why? You have the black nigger out there, is 100 kilo. This is like Zion Williamson.
Who's that?
Basketball guy. Talk to me, bro. It was my age. Talking 198 120 kilo.
120 kilo, bro. That's further is obese, bro.
Bro, search up Zion Williamson, fucking muscle ball, bro.
120 kg, oh, sure not. Bro, is obese, bro.
220 pounds.
Name again?
Zion Williamson.
Zion.
Zion Williamson. Zion Williamson. Fucking muscle ball, bro. Jump so high, man. That fucking bull.
Wow. Really, wait. He run towards you, you die, bro. It's like a charging bull towards you. Because Asian, Asian, you see what we eat, bro. Now, guys, now, let's look at the propano. Okay, you see, if I were to oxidize a propano, okay, you will get an aldehyde or carboxylic acid, correct? Okay, guys, if you oxidize this, you see what you'll be getting? You might be getting a carboxylic acid or an aldehyde, right? Alright, guys, now let's look at an alcohol. Example, guys. Okay, when you see an alcohol, right, you always have an OH bonding. So, guys, remember this, OH is a giat. How to spell gyat? G-Y-A-T-T. Yes, correct. This is a gyat. Which means you always have a fat pig like that. Okay, so when you have a fat pig, yeah, okay, that is in between 3,000 to 3,500. This is always due to OH. I remember that. Please, whenever you see a fat pig around 3,000 to 3,500, that is always due to OH. Clear? Okay, now guys. Okay, what if you have a double bond O? Alright, guys, if you have a double bond O, right, this double bond O, you always have a short, okay, a short peak, approximately 1,700. Yes, ketone aldehyde, anything with a C double bond O will always be around, okay, around 1,700. That's it. Please, Hassan. Alright, guys, once done, next page. Let me show you another one, which is a carboxylic acid. Alright, guys, for a carboxylic acid, right, you see, you have a double bond OOH. Okay, when you have this double bond OOH, this OH, always remember, carboxylic acid will give you a very big gap. Why are you guys teaching me all these languages? Shit, man. Well, you have a very fat pig, like very fat one. So as long as it's a carboxylic acid, remember this, okay, the pig, right, it's always from 2.5 extended all the way to 3,500. Yeah. Can see that or not? The value is so huge. Okay, so you have a very fat gap. Okay, for carboxylic acid. Alcohol is still a gap, but it's just 3,000 to 3,500. But carboxylic acid is so big, bro. Okay, that's how we differentiate carboxylic acid from alcohol. Please. Oh, good. Alright, guys. This is due to OH. This is due to a C double bond O. This part is kind of nonsense. If they ask you, you can refer it's a C single bond O. But I don't recommend you guys to find it because this is under fingerprint region. It's very messy. Okay? Alright, guys, once done, next. Alright, guys, let's look at alcohol. Alright, for alcohol, right, guys, can see that you have a gap, but it's not too big. Do you see that it's 3,000 to 3,005? This is definitely due to OH. Alright, guys, you also see this ding, right? Alright, guys, I want you guys to highlight this. This is the most useless one, yeah. Okay, because this will be present in all compound. Reason, this is a CH. Okay, and this is present in all, yeah. Okay, your CH is always present in all, and he also have a CH one. Get me? So usually we don't use the CH to identify because we can't really use CH to differentiate anything out of it. Alright, guys, so And for ester, you see that there's no OH, right? You see no big gap. This is due to, as what I mentioned, that's the most useless one, is a CH. This is the important one, guys. With number around 7,000, 1,700 is C11O. Okay, explanation, you can write it as C11O in an ester. And this is a strong absorption, that's it. Other you don't really need to identify already because it's way too messy. All good. Okay, once done, next page. Guys, I'm moving on quite fast. On one reason, this chapter is easy. It's more application. How about the page, I can? Alright guys, next. Let's look at the ketone. As you can see, ketone has a C11O. Do you see a C11O here? That's it. Around 1,700 C11O. Reason? And the carbonyl. And it's a strong absorption, right? Guys, you see? Do you see the useless one is still here again? So this useless color is always there. So try not to use this useless to identify because it can't be used to identify anything. Oh, good. All right, guys, we have hydroxy acid. Okay, let's look at it, guys. What do you see? That, yeah, right. Okay, this is definitely due to a OH. Get me or not? Okay, what else do you see? You should have a double bond O, right? Because you have a COOH, right? So a double bond O is here. Clear? That's how we identify, guys. The 2005 to 3005 is due to OH. So like I mentioned that, right? Your hydrogen bonding in carboxylic acid and alcohol both combine, right? Okay, to give a very broad picture. That's it. C11O and OH. Both. C11OOH and also OH. Everything combined. Okay, all the OHs combined to get this very fat gap. Here, please write down. Alright, guys, next page. Oh, good. Alright, guys, infrared spectrometry of a primary amine. Alright, guys, for primary amine, the special part is just NH. So NH is always here. It's a very weak one. Okay, but you see that this is not a fat yet. Okay, this is not considered a fat yet. Okay, so for NH, right, you always have a value around 3003 to 3005. And the property, right, you will see it like a W, yeah. And it's always a weak absorption. This is not a strong one, it's a weak one. That's it. So amine, you always have this property, yeah. And guys, we are done. So chill this chapter. Balik rumah tak boleh.
因为我们 still have 30分钟。
Yeah, we still have 33分钟. So guys, I want you guys to flip to next part, which is mass spectrometry. Let's go.
IGCSE.
What IGCSE? Mass spectrometry.
No, it's not IGCSE.
It's not. Guys, page 14 next. Come. Very fun one, mass spectrometry.
IGCSE.
Very good. Mana ada IGCSEs?
I've seen this before.
Alright guys, let's go. Come. Okay, what we have here is a mass spectrometry. Guys, for mass spectrometry, right, what we use to measure? We can use to measure a relative molecular mass. Okay, we can also use to measure relative abundance. Okay? Okay, guys. So this is how a mass spectrometry look like. You don't need to know. Okay, how it works, right? Electrons from the molecule and break the covalent bond. You send an electron over, okay, then they're gonna break a covalent bond and fragmenting the molecule. Yeah. Okay. Alright, guys. What do you mean by fragmenting the molecule? You see, let's say if I have an ethanol, right? Sorry, if I have a propanol. And guys, I'm sending a high-speed electron over. It's gonna bombard this, and eventually, right, they're gonna start breaking the bond. So this bond will start breaking, Got me? So for example, right, if you set it here, boom, the bond is gone. So you get this thingy and another thingy. So these are some example of the fragment, yeah. Or also maybe you get this thingy also. Can. So you see, right, there's multiple way a bond can be fragmented. Okay, so basically you can turn into a CH3 with a plus, correct or not? This one? Okay, right here. If you fragment this, it's gonna be CH3 plus. Okay, if you fragment this, also a CH3 plus, correct or not? If you fragment here, okay, so CH3, CO, right? Okay, it turns into different part, yeah. There. So that's how mass spectrometry works. It will start fragmenting the molecule. Okay, now. So guys, unlike your infrared spectrometry, you read it from the left. Mass spectrometry, you read it from the right. I want you guys to read this way, always from the right. Reading from the right is going to be so way easier for you to do it so. Alright guys, first step, I want you guys to read from the right. When you read from the right, and please look at the first tall peak, a very tall peak that you see. That would be my MR. Okay, so you read from the right, the very first tall peak that you see, like a Joe boy looking peak that you see, tall boy. Wow, okay, that's your MR. 80 kilogram. Wow. Exactly, you have to bulk to 100. You'll be like a walking pyramid ball. Damn sexy. Okay, so guys, first you see if I read it here, dum 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 dum. This is the first bit I see, right? Okay, so guys, this thingy, I read a 58. This is my M plus. M plus is also known as molecular ion peak. Guys, remember this. In order for it to be M plus, it must be quite tall. You cannot take a short one as your M plus. Okay, so your molecular ion peak is always equals to MR. In this case, guys, if you were to calculate the MR, how much is it? 12 times 3 plus 6 plus 16. 36, 42, 16, 58 gram. You see it's the same. Which is a C3H6O. Okay, guys, always remember when you're writing your fragment, right? Remember to put a plus. If there's no charge, you lose mark immediately. Okay, must be a plus, please. There you go. I go with water. Go. Let's go. Okay. Why is it a plus? Because when you break the molecule, okay, so there will be one electron short, Okay, so it's gonna be one electron short. That's why it's a plus. All right, guys, next. Second, I want you guys to look at your highest peak. Okay, the highest peak, right, which is this one, Okay, this highest peak, right, okay, it's just known as a base peak. Base peak is kind of useless. We don't really use it. Okay, we hardly use your base peak for. Okay, you cannot use base peak to identify anything. It's kind of useless. So in this case, my base peak is a 43. Okay, and this indicates it's a most common ion, which is why is it a 43? This entire thing, that's a 43 gram. So your base pair is a COCH2. Done. Okay. And finally, guys, we have a 15 here at one corner. A 15, right? It's just a CH3. Yeah. Done. How do you know it's CH3? No, because you add up the mass of 12 plus 3, right? Okay, me. That's it. All these values are your mass, you know. Can I? Good. Alright, guys. Highest mass over charge ratio is basically our MR. Yeah. And guys, remember this MR, it must be quite tall. If MR is not tall, if M plus is not tall, that is not your M plus. Tallest line, that's your base peak. Yeah. That's it. One side, next page. Alright, guys, now let's move on. Alright, guys, sometimes, okay, let's look at your x-axis. Your x-axis, right, is always a match over charge ratio. Okay, so remember that it's always a mass over charge ratio. Alright, guys, you see. Now I will show you. Okay, this one is basically the abundance. Okay, I will show you some example. You see, let's say like, hey, my screen frozen GG. Wow, no, tell me. Yeah.
We just experiment.
The screen isn't refreshing. Can't see. Hi guys, now let's say. Alright, I will show you guys a few examples. Alright, so Cu has two isotopes. Just imagine we have a 63 Cu. Got ghost. Shit, guys, got ghost here. Cannot be a Ramadan month. Ghost also no energy to come out, right? They fasting. I think so. Not ghost. 64 Cu. How?
India goes. Have to be Indian.
It doesn't mean. Alright, so guys, you see, if I put a 63 here and 64 here, I think you guys know what it means, right? So please tell me what the 63 is, what the 64 is.
Oh, it's isotope.
Yeah, 64 is the isotope, right? So basically, this is a 63 Cu with a plus. Don't forget, 64 is a 64 Cu with a plus. Understand or not? Okay, guys, let me show you something sexy. Ayuh. I think all the Malay like you. Oh, we have 63. Alright, guys, can you explain to me what is 31.5 and 32? Yeah, please explain to me what's a 31.5 and 32.
Oh, yeah, I know it.
Ah,
No, like Like your pole is like 197.
Half of the Cu atom cannot be half of the atom. How can it be half of it? Cannot.
Okay,
It's not an impurity. See, anyone can explain. I really highlighted for you. The keyword is mass over charge ratio. Anyone? Two, almost. Isotope charge.
plus.
Yes, correct. The answer is a 2 plus. Well done. So you see, our 31.5 is a 63 Cu, but with having a 2 plus. Get me or not? Because you see, this is mass over charge ratio. Get me? 32 is a 64 Cu with a 2 plus also. Understand? Alright, guys. Please write it down. Okay, guys. Okay, Alright, guys. Look at this example. I want you guys to label everything. 15, 27, 39. Okay, please label everything for me. By the way, M plus, okay, it's shown right. Okay, so basically your M plus is a CH3, COCH3, right? Okay, label everything, I'll go.
What's 42?
听懂我就这样。
C3 CO minus cannot put minus.
That's how you get all this value is by try and error the masses here. For example, this thing is gonna be a 15, right? Guys, how they go from 15 to 27? Plus 12, which means plus a carbon. C2H3. Guys, how to go from here to here? 27 to 39? Plus 12 also. Correct or not? So which means C3H3. Guys, how to go from 39 to 42? Plus 3. Only possible answer is plus 3 hydrogen. C3H6. What about 43 then? If I take this out, I get a 58 minus of 15, right? Why not? So you take out a CH3, so the answer is a CH3CO. Know how to identify all the pig, Clear? Alright, guys, next. Let's go. Okay. Right now, let's look at the M plus 1 pig. So, guys, what we use M plus 1 pig for, right? Remember, is to find the number of carbon. That's it. Okay. Purpose of us having an M plus 1 pig is to locate the number of carbon. That's it. Alright, guys, why is this so, right? Because this is due to one of the carbon atom, right, is an isotope. Okay, what isotope is that, right? It's a carbon-13 isotope. Okay. Alright, guys, right now, let's look at your M plus. You see, if I read it from here, the first bit I see is here. This cannot be M plus. Reason being, this is way too short already. And guys, always remember, right, my M plus 1, I want you guys to put another here. M plus 1 pick, right, is very small. Okay, my M plus 1 pick, right, is always very small. Okay. So guys, now you see, this is my m plus 1. Reason being is very small. And the next one that you see, this is your m plus already. So if you look at the value, right, my value is 41, 2, 3, 4, 5, 46. Your m plus is 46, can see or not? So your m plus 1, right, this is 47, yeah. Alright guys, why is it a 46? Let's draw out and add the node. How we calculate the MR, guys? You see, to calculate the MR, we have 2 carbon, we have 6 hydrogen, we have 1 oxygen. 32, 24, 30, 46. So do you see that your M plus is also equals to 46? Understand or not? Alright guys, let's explain on the 47, yeah. So you see, right guys, there will be 1.1% of the carbon being a carbon 12, a carbon 13. So what do you mean by that, right? You see, guys, let's say if I take a carbon in the air, so 98.9% of the time, right, you'll be getting a carbon 12, and 1.1% of the time, you might be getting a carbon 13. Get me? So touch wood, the 1.1% actually happens. So you might have a 13 here, carbon 13 and carbon 12. So now the new calculation is going to be 12 plus 13. So you have 1 carbon 12, 1 carbon 13, 6 hydrogen still, 1 oxygen still. Right now it's a 47 gram. Can see or not? So this we call it as n plus 1. From 46 gram turn into 46.7 gram. Reason? Because of a carbon 13. Get me? Understand the concept? So guys, always remember this. Carbon 13 is always represented by your n plus 1. Alright guys. Okay, so to conclude, okay, how do you find the number of carbon atom? The number of carbon atom is represented by this formula. 100 divided by 1.1 multiplied by n plus 1 peak ratio over n plus. Okay, this is the intensity. We are taking the y-axis value. Understand? Don't sub in your mass over charge ratio. We are taking the y-axis value. That's it. Please write down. Alright, guys. Okay, that's it. With a molecular ion state of X plus. Okay, what happened to my screen? Next page. Okay, with a molecular compound of X, okay, N plus, and abundance is 54.5%. Okay, so N plus 1 is 3.6%. How many carbon number? Okay, so guys, how do you find your carbon number atom again? So first, I can use my number of carbon formula. What is it? 100 over 1.1 times abundance of m plus 1 over m plus abundance, which is a UV. M plus 1 is 3.6%. M plus is 54.5%. Press your calculator. How much is it? 6 carbon done. Okay, alright guys, next. Wait, why not sing one? Okay, a compound that consists CHO atoms have a molecular ion peak and mass to charge ratio 1:2. Okay, so and abundance is 35%, n plus 1 abundance is 1.5%. Calculate number of carbon and what is the molecular formula of this compound. So guys, how to do this question? First step, what I want you guys to do is, okay, guys, can you find me the number of carbon? Go. Well done. Okay, n plus 1 over n plus, let's go. Okay, then I get 100 divided by 1.1. M plus 1 formula is 1.5%. M plus is how many percent? 35. Final answer? 4. Yes, the answer is 4 carbon. Alright guys, once you have your number of carbon, right, the next thing that I want you guys to do is to find your molecular formula. So guys, what is my molar mass? My M plus, right, is also equals to my MR is 102, yeah? Get me or not? So guys, the total number of total mass is 102. So I know that, right, inside you have 4 carbon. So I can minus off 4 carbon first. Okay, so what's the mass left? 54. So guys, out of this 54, right, it's contributed by either hydrogen and oxygen, correct or not? And guys, for a C4, you cannot have 54 hydrogen. Okay, so we try to minus oxygen first. Okay, so I can straight away minus 2 oxygen away because 1 oxygen is 16. If you minus off 16, the number is still too big. How much? So you get 22. Guys, again, cannot have 22 hydrogen also. Correct, because C4 doesn't have. So again, 22 is still kind of big number. So I can minus 1 more oxygen here, minus 16. So you have 6 left. So technically saying I can minus off a 6 hydrogen here. Then you get 0. So my final answer, right, it's gonna be C4H6O3 because you have 3 oxygen. 1, 2, 3, 6 hydrogen. That's it. Okay, I want you guys to move on to another page. Alright guys, let's look at page 22. Alright guys, jump. For page 22, using n plus 2 and n plus 4 page. Okay, so usually in exam, right, okay, we only cover up to n plus 2. N plus 4 is not really popular. So I can say that if the sample contains chlorine or bromine, we always get a peak beyond the molecular ion peak. So chlorine, right, have 2 isotopes, which is a 35 Cl and also a 37 Cl. Yeah. Okay, so does bromine, 79 bromine and 81 bromine. Alright guys, next. N plus 1, right, we always use to identify a carbon number. Okay, for a chlorine and bromine, right, we always get either N plus 2 or N plus 4 peak. That's it. Alright guys, now let's go. Alright guys, 1 chlorine per molecule. Okay, I will show you how to get the answer for 1 chlorine. So just imagine, right guys, I have a R This R is basically any CH3, and then I do a CH3. Okay, I have a CH3 bonded to a chlorine. Okay, so guys, let's look at your chlorine again. In atmosphere, right, what is the composition of chlorine? So composition of chlorine is like that, Okay, 75% of the chance you'll be getting a 35 chlorine, and 25% of the chance you'll be getting a 37 chlorine. So that's the composition. So chlorine 37, right, is 25% of the chance you'll be getting a 37, and chlorine 35 is 75% of the chance. Get me? All right, guys, now let's look at the chances of getting m plus 1 and also m plus 2, okay? So guys, now first let's look at if I have a CH3 bonded to a 35 Cl, okay, what it will be? So what's the mass? CH3 is a 15, so 15 plus 35, right, it's 50. Okay, so this is 50 gram. Okay, and guys, for 50 gram, right, this is the lowest possible mass that it could be for the molar mass. So this we call it as M plus. Understand? Alright, guys, let's say right, if your CH3 is bonded to a 37, what's the mass here then? So it's gonna be 15 plus 37. Do you see it's 52 gram? Can you see that this is also written as the mass plus 2 unit? Get me or not? Alright, guys, now. Okay, we have M plus and M plus 2 already. Kid, what is the chances of getting an M plus? You see, right, the chances of getting an M plus is 75%. And the chances of getting an M plus 2, right, is 25%. Correct or not? So which means, guys, what is your M plus to M plus 2 ratio? It's a 75% to a 25%, which means the ratio is 3 to 1. Okay, so let's say in the graph, right? Okay, you always see your M plus standing about 3 times the height of your M plus 2. Okay, so if you see 1:3 ratio, 3 to 1 ratio, it's always indicating a chlorine. Okay, Okay, so one more time, 3 to 1 ratio is always indicating a chlorine. Done. Understand? That's it. Please write down. Alright, guys, nice. Okay, simplified. Blah, 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 blah. Oh, this one don't care. So the molecular ion, this one, oh my God, I can just ignore the entire thing. Don't care. So annoying. I'm going to remove this already. Don't care. Skip. Alright, guys, once done, I want you guys to look at next page. Alright, guys, now let's look at the 1 bromine per molecule. Alright, guys, let's say if I have 1 bromine, okay, just imagine this. I'm going to take a bromomethane. I have a CH3 bonded to a Cr. Alright, guys, the funny thing about bromine, right, is under the atmosphere, let's say if you were to capture a bromine, right, 50% of the chance you'll be getting a 79 Br. 50% of the chance you'll be getting 81 Br. Okay, so the ratio, right, it's always 1 to 1 ratio, for Br. Alright, guys, now, what are the chances of getting a CH3 bonded to a 79 Br? So if you look at the mass, right, it's 15 plus 79. The answer is 94 gram. Correct or not? And this is the lowest possible mass. We call it as M plus. What about if there is a 81 Br? 15 plus 81, you get 96 gram now. And look at the mass. Do you see that the mass increases by 2? And guys, the composition is always 50% to 50%, right? Get me? Alright, which means, guys, let's say if you were to look at your M plus and M plus 2, the height is always 1 to 1. Get me or not? So the height is always a 1 to 1 ratio. Done. Clear. Please write it down. And guys, with that said, we are done with the syllabus. Yeah. Remaining part are just practices.